Okay, so we're going to continue talking about solving for rational expressions. Okay, so with this one, we're going to look at x minus 3 over x plus 3 equals x over x plus 3. So we need to get rid of that x plus 3 on the denominator and find the least common multiple to figure this guy out and solve for x. So with this, let's multiply by the least common multiple to cancel out the denominators. Well, with that, we're going to multiply by x plus 3 since it's the same denominator for both, and we can get rid of them that way. In which case, you'll see that you can take the x times x plus 3 minus x plus 3 times that fraction, and same thing on the other side of the equal sign. When you have equals x over x plus 3 multiplied by x plus 3, you'll see these guys will cancel out. Okay, so we should be left with x plus 3 times x minus 3 equals x. So when we cancel out the denominators, that's what we're left with. X plus 3 times x, then minus 3 equals x. Now let's go ahead and distribute and get these all squared away. So we take this, again, x times x gives us x squared, and then x times 3 gives us 3x minus 3, and that equals x. So now let's combine like terms. So to do that, let's go ahead and subtract x from both sides. In which case, we'll be left with x squared plus 2x minus 3, and that equals 0. Now, we need to factor out the left-hand side of the equation here. And so when we factor that out, you get x minus 1 and x plus 3. Now to do that, to find our answers here, we need to set those both equal to 0. In other words, we're going to take x minus 1 equals 0. That's where we have to add 1 to both sides. So on the left hand side, those 1s will cancel out, and you have x equals 1. And then we're also going to take x plus 3 equals 0 and solve for x. So subtract 3 from both sides. 3's will go away on the left hand side, and you have x equals 3. So we should get, minus 3. Left my negative off. X equals negative 3. So we should get x equals 1 and x equals negative 3. Or another way you can look at this is if you just want to switch the signs of those in the monomials there. So we have x minus 1, just make that 1, the negative 1 to a positive 1. And you have x plus 3, if you take that positive 3 and just make it a negative. As you saw when I did there with the calculations, that's what you got to do. Alright, so now back in the original equation there, up in the top left-hand corner, we're going to take what we found for our answers and see if they both check out to where we don't have any division by 0 by substituting in all those values. So if we put in x equals 1 and we plug a 1 into all the x values in the initial equation, that's how it's going to look right there. In which case it simplifies down to, we would get 1 minus 3 over 4 equals 1 over 4. And 1 minus 3 over 4 is the same thing as saying, if you're going to do common denominator here, get this going, a 1 is the same thing as saying 4 over 4 is the same thing. Alright? So if you do that, you just see that you would get 4 minus 3 would give you 1/4. So it should have 1/4 equals 1/4, or 0.25 equals 0.25. So with that, this checks off. We're all good. So the 1 works. Now let's check to see if we have the negative 3. So let's plug in the negative 3. And then we'll get negative 3 minus 3 over 0 equals negative 3 over 0. Because as you see right here in the denominator, you have a negative 3 plus 3. Well, as it's saying 3 minus 3, which gives you 0. So with that, you cannot divide by 0. So we're going to reject negative 3. So our final answer for this one is only a 1. So when you do these problems, and if you come up with two answers, that's fine. You just need to check to see if they both work or just one of the answers work. So our final answer would simply just be number 1 for this equation. Let's do another example. So this one, up at the top left corner, we got x minus 3x plus 2 over x plus 1 and equals 1 over x plus 1. So let's find the least common multiple to cancel the denominators, which as you can see should be x plus 1. And we're going to multiply it through. And when we do, on this first setup, we'll get x plus 1 times x. This x plus 1's on the second part here will cancel out, as well as with equal, this says 1 over x plus 1 times x plus 1. These guys cancel out as well. So it should be left with x plus 1 times x minus, in parentheses, at 3x plus 2, that equals 1. Okay. Now, we're going to need to make sure we distribute that negative 1 in front of this guy here, because there is a negative 1 here. So it's going to change the signs of everything inside the parentheses, and we're going to distribute this x into this first setup here in the monomial of x plus 1. Okay, so as you can see, we took x times x gives me x squared, and then x times 1 gives me plus x, and then you take negative 1 times 3x, which gives me negative 3x, and negative 1 times positive 2 gives me negative 2, and that equals 1. So we got that set up there. Now we're going to combine like terms. So if we take x squared, can't do nothing else with that. We take our positive x and our minus 3x, well, it's saying negative 3x plus x, so we get a negative 2x, still minus 2. So now let's make it all equal 0. So to do that, all we did was we subtracted this 1 from both sides, and that gave us the negative 3 over here, and gave us a 0 on the other side of the equal sign. So now we need to factor this guy out, and looks pretty similar to the problem we had before, right? Same numbers, but we're going to different signs. Again, you can look in here and just say that you said have x is equal to 3 and negative 1, but if you like to work it out, and just set each one of those to 0 and solve for it. Again, you have x minus 3 equals 0. So we're going to add 3 to both sides. And we're going to left with those guys go away. So we got x equals 3. And same thing over here when you have x plus 1 equals 0. So we'll subtract 1 from both sides. And we should have x, these ones go away, equals negative 1. So our values that we should get for this one are a positive 3 and a negative 1. Or as it says there, you can just switch the signs, as we talked about. Now, back in the original equation we have here, let's check to see for division by zeros. So let's take our first value of 3, plug it into the equation there. Okay, so looks like we're doing good so far, because on the bottom there for the denominators you take 3 plus 1, that should give us a 4. So when we do that, we have this set up right here, and to do this we should just be able to subtract those fractions right there, and that should give us 0.25 on either side there. Now you can do this as well if you don't have a calculator, you don't want to use a calculator to do that. Again, remember, this is 3 over 1, right? So if we want to make it a 4 down here, you multiply this times 4 over 4, right? Which this would give you, for this fraction up here, we give you 12 over 4. So if you took 12 minus 11, that would give you 1, and you still have the denominator 4. So that would still equal 1/4 over 1/4, which is 0.25 equals 0.25. So the 3 works. So that guy's good. Now let's check on the -1. So we take our -1 for x value, plug it in the digital equation, the original equation, and I already see a little bit of a problem here. If you look at the denominator, if we put a -1 plus 1, that's going to give us a 0 on both of these. So that's not going to be good. We don't need to divide by 0. So we're going to reject the -1. And our final answer will be 3. So in these two examples that I did with you guys, yes, we had 2 possible values for x. However, only one of the values worked for it. Now that's not always the case. Both answers that you come up with, depending upon the initial problem, could work. Both answers, you could get 2 answers that work. Okay, but in the problems that I did, only one of the answers we found did work. Alright, so hopefully that explains a little bit more on solving for rational expressions, and you learned a little bit of something today, and I'll see you next time.